relation and function எதனால தெரிஞ்சுக்கணுமா? இப்போ think about this. See this person, Godfrey Willem Leslie. His work is around 26 topics. Around 26 topics he has done. 26 topics he has completed. Okay? Not only in mathematics, in geology, medicine, biology, epidemiology. What is epidemiology? What is epidemic?
Epidemic is like
Okay. Which spreads quickly. Okay. So what is the pattern in that? Everything is related. He went through all this. What is paleontology?
study about
Olden people and their lifestyle. Everything is paleontology. Psychology, engineering, philology, sociology, ethics. He did all this work. So function and relation, everything have a relation between oneself, and especially it has a mathematical number. Do you know what is Fibonacci? Actually, the arrangement of petals of sunflower or sunflower சாமந்தி, இது எல்லாமே வந்து அந்த ரூல் தான் போகும். It would be like this: 1, 1, 2, 3, 5, 8, 13, 21. Arrangement will be in this number. That is 1, 1. First is this 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 8 plus 13, 21. Okay. What we are going to understand in this chapter is to define the Cartesian product of sets. What is product of sets and how to get the Cartesian product, then to define the subset. You already came across this power set and subset. All right. By answering the question, I could see that you already know what is power set and the numbers in power set. The thing you told, n square, is number of terms which would be in that power set. If all the subsets are combined, that would be n square terms. Okay? Then how to represent in arrow diagram, set of ordered pair, a table, a rule, or a graph. How to represent things. To classify function as one-on-one, one-to-one, many-to-one, onto function, into function, and bijection or bijective function. Bijection or bijective function. To study the combination of functions through composition. F of G, G of F, F of G of H. Like that, we will be combining. There will be a systematic tool. When you understand this tool, you can see pattern in everything. When you understand the pattern, automatically science, social, whatever you're working, you'll be good in that. Okay? That's why we are working on relations and functions. First, to understand Cartesian product, we have to understand ordered pairs. If you are going to a cinema theater, there will be, your number would be P12, P13, P14. Right? So this P denotes the row and 12 denotes the column of it. Likewise, so P and 1 is one ordered pair. It will be designated to one person. That is what ordered pair is all about. Let's think about this illustration. If you are going to work on having one vegetable and a fruit on daily basis, what kind of order we can have? See, if carrot is C, brinjal is B, and lady's finger L, and fruits, apple, orange, grapes, and strawberries. One vegetable, one fruit. So carrot, apple, carrot, orange, carrot, grapes, carrot, strawberry. Likewise, brinjal, apple, brinjal, orange, brinjal, grapes, brinjal, strawberry. Lady's finger, apple. Likewise, we can have this many number of this many number of pairs. What all the maximum pairs which we can get. This is known as the universal set. The set of all pairs is known as universal set. So, by definition, if A and B are two non-empty sets, then the set of all ordered pair A comma B such that A, small a element of A, small b element of B is called Cartesian product of A and B and is denoted by A cross B. We say it as A cross B. It's not A into B, it's A cross B. And you may come across dot also in future, A dot. For normal multiplication, we will consider cross, into, and dot as multiplications. But in some places, this cross represents something else and dot represents something else. You'll be coming across the same while you're working on signs also. Scalar product, vector product. Vector product would be cross product. Scalar product would be dot product. You'll be coming across that thing in future. Don't worry about it, but we have to understand those sets, all right? Okay. What and all we are doing in A cross B? All possible ordered pair we are writing. Number one, all right? First coordinate, A is the first coordinate and B is the second coordinate. In ordered pair, A comma B, first coordinate and second coordinate. Right? Then, what other things we can say? B cross A is the set of all possible ordered pairs between A and B such that the first coordinate is B and second coordinate is A. Right? Second coordinate is A. Think about this. In general, A comma B not equal to B comma A. 1 comma 2 not equal to 2 comma 1. Are you familiar with this graphs? Graphs. You know how to plot 1 comma 2, 5 comma 6. So each and every point differs. 1 comma 2 is not equal to 2 comma 1. Okay? So here in the illustration, second illustration, we got A and B. We have to write the Cartesian product of A cross B and B cross A. So A cross B would be 1A, 1B, 2A, 2B, 3A, 3B. And B cross A is A1, A comma 1, A comma 2, A comma 3, B comma 1, B comma 2, B comma 3. Okay? So when we put it in graph, x-axis is 1, 2, 3, and y-axis is A, B, C, likewise. It is totally different. So this is not same. But when we think about the number of terms, number of ordered pairs, number would be same. Number would be same. How is that possible? Okay. So from this example, we come to know that A cross B not equal to B cross A, number one. But number of terms in A cross B and number of terms in B cross A is same. All right. All these are very important for 1 month. Most of the people who are getting above 90s will be losing marks, especially in 1 month. Okay? That's where they are missing. Okay? Then A cross B. What is this symbol? Null set. That symbol in Greek alphabet, it is known as pi. Small alphabet of pi. The capital alphabet would be pi. Small one would be this one in Greek. Okay? We'll be using a lot of Greek symbols while we are working with mathematics and science. Like rho. This is density. Sigma. Surface density. Lot of things will come across. We have to understand those also. Then alpha, beta, gamma. All right. Alpha, beta, gamma, theta. All these are especially symbols. Okay. Can you give an example for universal set? You're going to give an example for universal set. Number one, then set A, then set B. Your own choice. I want you to create your own choice. Okay?
Set A 1,
1, 2, 3,
set B 4, 5, 6.
4, 5, 6,
Set 1,
1,
4,
4,
1, 5,
1, 5,
1, 6.
1. Oh, these are ordered pairs you are saying. Okay. Universal set as like this. We can take some more different examples too, so that we can have intersection, we can have union, and also let it be universal set of natural numbers less than or equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A. We can take it as prime numbers. Okay. So 2, 3, 5, 7. Okay. Set B can be odd numbers. 1, 3, 5, 7, 9. Set of prime numbers less than 10. Set of set of odd numbers less than 10. Okay. So what is union of AB? What is A union B? 2, 3, 5, 7, 1, 9. Okay. 1, 9. What is A intersection B?
3, 5, 7.
3, 5, 7. What is A difference B?
1,
Hmm?
1 and 9.
1 and 9. A difference B or B difference A? Which one was?
A difference. So now it's 2.
Okay, very good. 2. All right. 2. What is B difference A? 1,
9.
9. 1, 9. So from this we can deduce that A difference B not equal to B difference A, number 1. Then union, intersection we have done. Next, can we put another thing, C also? Set of even numbers. 2, 4, 6, 8, 10, less than or equal to 10. So we have 3 sets now. So there will be a lot of difference. We can go through A union B, B union C, A intersection B, B intersection C, and A intersection C. This is how we will be creating questions. Someone will be creating question like this, and you will be answering the questions. When students start creating their own questions, they will not forget how to answer it, because they know how the question is well formed, and applying the same concept, they will be strong in all aspects. Okay? Why I want you to work on this is, when you understand the first fundamental rule, you will definitely get to the answers. Okay? We went through all these because we need to understand whatever questions we are going to progress in future. We need to understand. Okay? And we know what is null set. Null set can be denoted like pi or without any term. Some people, if they add like this is not null set. Both cannot be added. This will be in a choice. In a choice in your mathematics, choose the correct answers too. Okay? But a lot of people would be thinking that this is also null set and it's this one. That is not true. Only if, when we would get null set of A cross B is only if both A and B both are null set, we would be getting A cross B as null set, right? Any one term should be null set. Then we won't be getting any ordered pair at all. If n of A equal to P and n of B equal to Q, then automatically number of terms in the Cartesian product would be P into Q. So in this, we have 2 into ns2, ns2, ns3. So automatically 2 into 3, 6 we will be getting. Right? Next, for an example, let A be set of numbers in an interval 3 to 5 and B set of numbers in interval 2 to 3. Then the Cartesian product will be. See here, this is known as closed set. Closed set. That is any number or point between 3 to 5, between 2 to 3. So automatically you would be getting an area. You'll be getting an area. Here we have specific number, natural number. There will not be any in between number. 1.5 is not a natural number or whole number. But when they tell this like 3 to 5, automatically from 3 to 5 it can take any value, and 2 to 3. Within 2 to 3, it can take any value, 2.1, 2.3, 2.001, any value it can take. So it forms an area, right? It forms an area. For any two non-empty set A and B, A cross B is called as Cartesian product. Okay, A cross B is known as Cartesian product. Cartesian product. If n of A equal to 20 and n of A cross B is 20, n of A equal to 5. What is n of B? 4. If A is minus 1, 1 and B is minus 1, 1, then geometrically describe the set of points across A cross B. What and all points will be getting? If A is minus 1, 1, B is also minus 1, 1. Yeah. No. A cross A, whatever it is. Minus 1, minus 1. Go with the first term itself. Minus 1, 1. Minus 1, 1. 1, minus 1. 1, 1. So, like we already told, 1, 2, 3, 4. 4 points we have got. Okay? All right. If A to B are the line segment given by the interval minus 4, 3 and minus 2, 3 respectively, represent the Cartesian product of AB. We have to represent these points actually in graph. Okay. For that, do we have an option? Definitely. Why I take the classes synthesis, it will be useful for anyone. Even for graph or something, we can easily work on it. Which one we can do? Let's see. Numbers can be 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5. Always we should have an arrow mark at both ends. All right, because this is continuous, isn't it? X-axis, Y-axis. While you're working on graph, any graph, Whether they are given it or not, we have to write this scale. Right? Scale would be like this. On x-axis, 1 centimeter equal to x-axis, 1 centimeter equal to 1 unit. On y-axis, 1 centimeter equal to 1 unit. We got -1 comma -1. So the point would be this one, -1 comma -1. Then -1 comma 1, -1 comma 1, this point. Then 1 comma -1, 1 comma -1, 1 comma -1, this point. Then 1 comma 1, this point. We'll be answering that again. -1 comma 1, 1 comma 1, 1 comma -1, -1 comma -1. This is what we got. This is for the previous question. All right. For the second question, what they are told, interval, it is between this -4 to 3. All right. Then -2 to 3. So -4 to 3 would be like this, -4 to 3. All right, -4 to 3. This interval for number 1. Then the next one is -2 to 3. So -2 to 3. -2 to 3. Where is the intersection between these two? All right. Where is the intersection between these two? 0.0. So the resultant will be here. Totally, it will be here. That's the result we'll be getting. Right? Can we -4 comma 3? The point -4 to 3 is here, and next one -2 to 3. -2 to 3 is here. So the intersection part of both will be giving the result. Right? That's what we have to do for this one first. Right? So next, the set of all points of the Cartesian plane can be viewed as a set of all ordered pairs x comma y, where x and y are real numbers. What is a real number? 0 to infinity. Then it's same as whole number.
Real numbers includes 1
Hmm.
1
Okay. See here, natural number, positive. All right, 1 to infinity. Whole number, 0 to infinity. Integers is -infinity to +infinity. Only the exact full numbers. -10, -5, 0, 1, 2. So natural number is also known as positive integers. All right. Then we'll be going through the next type of numbers, real numbers. In that, we'll be having fractions, terminating fractions, non-terminating fraction, then irrational numbers. What is an irrational number?
Irrational numbers like the numbers between 1 and 2.
Irrational numbers could be of two types: non-terminating fractions or non-terminating fraction. Example 1/3, 0.33333 goes on. Then also square roots. This is also known as square root of 2. We can say square root of 2 as 1.414, but it doesn't stop here. It will be moving on. There will not be any repetitive. There will not be any repetitive. It will go on and on and on. And some numbers, it will be like 1.141414. 14 is repeating again and again and again. So this is repetitive number. If they put one dash like this, it means that this 14 is repeating. Right? So all numbers, points, shrugs. This is known as shrugs. Radical sign, square root, radical sign, exponents, radicand. All right. So all these numbers combine to form real numbers. Right? It will be like this. Real numbers will be like natural number. Natural number will be in whole number. Whole number. Whole number will be inside integers. Z. It is denoted by Z. Then this one, integers, then rational number, decimals, irrational number, all numbers combined together to form real numbers. Real numbers. All numbers combined together to form real numbers. With this as a base, we'll be proceeding, okay, to the next level, right? So that's what real number is all about. It can be any sets of numbers, right? So in fact, R cross R is the set of all points which called as Cartesian plane. In this graph, it goes to infinity, isn't it? R cross R would be all the points. R cross R would be like all the points, any point within this term, any point, whichever point you say, it may be this one, this one, this one, this one. All this is inside R cross R. That's what they are answering there. Why we have to note all these factors? This is where you will be getting all the 1 marks. This is where you'll be getting all the 1 marks. Right? Okay. Activity. Let A, x element of n, x lesser than or equal to 4. Then B, y element of n, y less than 3. Represent A cross B and B cross A in a graph sheet. We have to put that in a graph sheet too, right? Can we try to put it in a graph? Can we work this or we can move on? Okay, well done. That enthusiasm from you will enable you to work in any place. A lot of people think that students are not strong enough, but when they are given the opportunity, they'll be growing well. You're really doing well by moving on and taking that opportunity for you, right? We can take plain sheets inside. This question we are going to work. I'm going to create a graph for you for this question. We will create a graph first, then it will be easy for us to copy and paste anywhere and use that graph to work on it. One. One, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. Okay? X, X bar, Y, Y dash, positive and negative. Okay. Now we have the bigger size also. So what is the set A? Hmm. 1, 2, 3, 4. What is set B? 1 and 2. All right. What would be A cross B? What would be A cross B? 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2, 4, 1, 4, 2. Right? We have to put all these points here. We will take a specific color for A cross B. Right? A cross B. 1, 1. 1, 1. 1, 1. 1, 2. 1, 2. 2, 1. 2, 1. 2, 2. 3, 1. 3, 2. 4, 1. 4, 2. Right? Then for B cross A, what it would be for B cross A? 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4. So when we put this B, I'm going to denote it with red color. All right, denote it with red color. 1, 1. Again, this is same. Right, this is same. 1, 1. Then 1, 2. 1, 2 is also same. 1, 3. 1, 4. Then 2, 1. 2, 1 is same here itself. Then 2, 2 is same. 2, 3, 2, 4. So there is an intersection of 1, 1, 1, 2, 2, 2, 2, 1, and 2, 3. All others are not intersection. So from these, we can easily say these 4 are intersection and these are not intersection. If we minus A minus B, you'd be getting this one. If you put B minus A, you'll be getting this. So automatically, when we work with the graph, you'll really get the data immediately. So each and every activity which is given in your book is for a specific reason. When you do these kind of work, automatically you'll be getting the result. Okay, this is what I'm going to do. This is what I'm going to do. That's the reason they have designed this book. Actually, the book which has been designed by our government was done by a group of IAS officers. when you work your books from at least from 3rd standard to 10th standard, you can write any government exams, okay? Especially maths and science. Even if you're going for UPSC exam, or if you're going to do engineering and you're going to work on it, definitely you'll be moving up. Okay, that's what we need to understand from this. Okay, let's check the first example. First example, if A equal to 1, 3, 5, B equal to, find A cross B and B cross A. Number 1. Number 2 is A cross B equal to B cross A. We will find that it is not same. No, it is not. We will justify that. Then show that A cross N of A cross B equal to N of B cross A equal to N of A into N of B. All these is a combination, right? All these are combination. Check the example 2. First, we have to find A cross B. They are given A cross B. We have to find A and B. So, first coordinate is A. A is 3, A is 3, 3, 5, 5. So, only one we can take. Only one we can take. There should not be any repetitive in a set. So 3, 5 is the A. And B, 2, 4. 2, 4 is B. That's it. All right. Now, in third example, A equal to X element of N, X greater than 1 and lesser than 4. So it would be, what would be set A? Good. Set A would be 2, 3. Whole number, X greater than or equal to 0, lesser than 2. Then B 0, 1. Then C 1, 2. With these data, we are combining B union C, A cross B union C. First, we have to get B union C. What is B union C? 0, 1, and 2. 0, 1, and 2 would be giving B union C. Then A, we already have A. So 2, 0, 2, 1, 2, 2. First, we have to find B union C. B union C. Then A cross B union C would be 2, 0, 2, 1, 2, 2. 3, 0, 3, 1, 3, 2. All right. Likewise, next thing what they want is A cross B union A cross. So first we have to find A cross B. 2, 0, 2, 1, 3, 0, 3, 1. Then A cross C. 2, 1, 2, 2. 3, 1, 3, 2. So finally, you'll be getting the data. Now, when you find the union of these two, this is separate set now. A lot of people would get confused. What is union? Right? To write the union, first determine one set. Write the whole set fully. All right. And this union would be first without any option. Just proceed with 2, 0, 2, 1, 3, 0, and 3, 1. After this, go to the next one. 2, 1. It's already here, so we don't have to write it. 2, 2. It's not here, so 2, 2. Then 3, 1. It's already here. We don't have to write it. Then 3, 2. It's not here, So we have to add 3, 2. So when we compare these two, we'll be having the exact terms. Where we want to equate is okay. 2, 0 is here. 2, 1 is here. 2, 2. Yeah. 3, 0. 3, 1, 3, 1. So both are equal. First, identify the number of terms. Okay, number of terms is same. Then 1 by 1. If you check that, you'll be getting that. Likewise, A cross B intersection C. What is B intersection C? B intersection C is 1. Right? We have 1 B intersection C. Then apply that. Next, A cross B. We already completed A cross B and A cross C. They want the intersection. While doing intersection, check. For this also, check with each and every term. 2, 0. Is 2, 0 here? No. No intersection. 2, 1. Yeah, it is here. 2, 1 is one intersection. Then 3, 0. Not here. All right. 3, 1. Yeah. 3, 1. So this is intersection. This is what you'll be getting here. Right? This is what you'll be getting here. See, we have completed the sum direct set. Direct set. It won't be taking a lot of time. When we view different sets and numbers and points, it will confuse ourselves. But the sum is very, very simple. Right? It's very, very simple. First, we have to take all the ingredients, what and all we need. Before doing a sum, before doing the sum, what we have to do is, in question, we have B union C, then A cross B, then A cross C, then B intersection C. First, complete this B union C, complete this B intersection C, then A cross B, then A cross C. You would be already having the 4 before starting the first question itself. What are the requirements we have completed? Then what they ask for LHS, A cross B union C. Write that, put the data, get the result. Okay. It's just like cooking. Right? Mathematics is just like cooking. What all ingredients you want, you have to take and keep it next to you. Then you can easily put in the right manner and cook it faster. You'll be fast while cooking also. You'll complete it and you'll be free. Or else if I'm not having every ingredient, required ingredient, I have to go there, fetch this, fetch this, fetch this. It will be late. And the taste also would be different because I'm not putting everything in the right time and right medium, right heat. So it will not be tasting good. If I'm not having everything next to me, definitely it will take a lot of time. The same question, if you proceed in a bookish manner itself, one way alone, you'd be taking more time to complete this question. If you have all the ingredients beforehand, you're just going to apply the concept and get the result. If this is a 5-mark question, both these combined together is a 5-mark question, you'll be taking more than 10 to 15 minutes on this itself. That is not feasible for us. What is feasible, which is good for us? Completing this complicated big question itself within 5 minutes. You had to know your time, how much time you're working, what is the requirement you need. That is what needed. That's why I completed everything here. Okay, they asked for this, they asked for this. If I complete everything beforehand, the question will be simple. I'll be answering immediately. If they want a graph also, I'll be drawing the graph there. All right. I already have this ordered pairs and everything. I have a graph sheet now ready for you. I'll put all the points immediately, put a square or intersection there itself, and I can show that this is the answer. All right. That's where we have to be strong. Mathematics is very, very simple. Okay. Now let's check with Cartesian product. This is a property. What we went through now is actually a property using Cartesian union and intersection. There is a systematic property using difference also. You'll be coming across that question in your exercise. The property is A cross B union C will be A cross B union A cross B union A cross C. A cross B intersection C equal to A cross B intersection A cross. All right. Likewise, definitely you would be getting using difference also there is a formula. But there will be a slight difference. Union would become intersection. Right? There will be a slight difference. So we have to be careful when you note the minute points. It will be easy for you. We have to note the minute points alone to get the result. Okay. What is Cartesian product of three sets? Oh, ordered pair, we got 1, 2. What about three sets? See here, 0, 0, 0. What is the 0, 0, 0? Can you plot it? Why not? Why can't you plot it? See here, imagine this room. All right, imagine this room. This point, the edge, the corner, is origin. X-axis, Y-axis. You can easily plot 1, 1, 0, 0. This one is Z-axis. This is known as 3D point. All right. If you consider each and every point in this room as 1, 1, and here also we have 1, 1. So 1 feet, 1 feet, 1 feet. Here also there's a point. If I'm saying 3, 5, 6, it is okay. 3, 1, 2, 3. This point, and 5, 1, 2, 3, 4, 5. This point in the plane, and 6, 1, 2, 3, 4, 5, 6. So this would be the point 3, 5, 6. It is a three-dimensional figure. All right. 0, x, y, z is a graph. It's also a graph. It is a three-dimensional graph. All right. That's why we can easily get this. You will be coming across the distance between 2 points. Here is one point. Here is another point. This has coordinate in x, y, and z. X-axis, y-axis, and z-axis. The point here, it also has an x-axis, y-axis, and z-axis. And you can easily calculate the distance between them. When we understand the fundamental, you can easily proceed with each and every step. Okay? So let's check the given example. 0, A is 0, 1, B is 0, 1, and C is also 0, 1. Okay. A cross B would be 0, 0, 0, 0, 0, 1. Then 1, 0, 1, 1. This is the point. Right? Then check about this. A cross B cross C. So A cross B is this 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0. Then 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, So here there are 4 points. Here there are 2 points. 4 terms. N of A cross B is 4. This is 2. So 4 into 2, we will be getting 8 points. 8 points will form a rectangle. X-axis, Y-axis, and Z-axis. When we plot the point properly, when you join it, you would be getting a cuboid. You'll be getting a cuboid. This one, we got this one, we got a term, square. This will also be a square. Actually, this will also be a square because all the distance is 1 into 1 into 1 into 1. X-axis is 1, Y-axis is 1, and Z-axis is 1. So it is a cube. It looks like a cuboid, but the reality is it is a cube. So this is what you have to understand. When you understand the fundamental, the overall chapter would be Easy. All right. Okay. From this exercise, 1, 2, and 3. This is null set. See, null set. Automatically, A cross B would be 0. A cross A would be having M comma M, M comma N, N comma M, and N comma N. A cross A is possible. M, N, and also M, N. This is A cross A. A cross A is possible, but A cross B or B cross A is not possible for this. It is a null set. Here, 3 into 2. 6 terms will be there. Here, both are P comma Q. So, it will be like same, isn't it? All the answer will be same. You can easily deduce the relation, right? Now you understand the fundamental for this. You can work on this, all right? Then, check the second question. A, they are given 1, 2, 3. B, B is prime number less than 10. Okay, I asked you some questions before, isn't it? Why I asked is, if you know that, immediately you'd be answering. It will be just like the first sum. What's the answer for B? 2, 3, 5, 7. When you come across these prime numbers, there is something known as doublet, prime triplet. When two consecutive prime numbers have a difference of 2, it is known as doublet. Example, 3, 5 or 5, 7, 11, 30, 17, 9. All right, then 29, 31. All these are prime doublets. There is only one triplet. 3 consecutive prime number with difference of 2. 3, 5, 7 is the only prime triplet. There is a question in UPSC exam. Actually, this thing which I told now, it came in 6th standard. Right? It comes in 6th standard, doublet, triplet, and everything. I have to teach these things for the people who have completed the graduation and they are working for UPSC. All right? Because they are not confident. They have just worked on a question, got 2 marks, and forgot about it. This is not going to help you at all. You have to be strong enough with your result. Right? Okay. Check this one. So 2, 3, 5. How many terms you would be having? 3 terms and 4 terms. So 3 into 4, 12 ordered pairs you'll be getting. And here also 12 ordered pairs, but it will be of different order. Right? Then they are given B cross A. Find A and B. What would be A? -2, 0, 3. A is -2, 0, 3. That's what you have to be careful. This is B cross A. The first one is B. Our mind will perceive things. In mathematics, we'll be losing marks because we are not sure. Our mind will say first everything would be A cross B. So without looking into the question, we'll start answering. Most of the marks lost by a bright student, average for a bright student that is above 80%, will be like they will not look into the question properly. You come across this and immediately you rectify the mistake. But many will just write, okay, -2, 0, and they will proceed and say, oh, this is the answer. But it will be B. That's where they'll be losing marks. A student who is getting 95% in mathematics and 100% in mathematics would be having that sharp difference. You have to be sharp. This ability is known as arithmetic ability or analytical ability. Even if you want to go into one of the best college, there'll be a lot of competition. They'll be having an aptitude test for you to get into a college. The best institution for engineering is IITs. If you want to clear IITs, you have to write a joint engineering entrance exam, which consists of mathematics, physics, and chemistry. And in all these, all the fundamental mathematics and the ability for yourself to see the question and perceive what they are given and what they are asked for. That is the real requirement. If you put A equal to, it will be a wrong answer. That's how you can work on. They are given A, B, and C, well and good. Show that A cross A equal to B cross B intersection C cross C. So we have to first get A cross A. 5, 6, 5, 6. So 5, 5, 5, 6, 6, 5, 6, 6. Put B cross B. 4, 4, 4, 5, 4, 6. 5, 4, 5, 5, 5, 6. 6, 4, 6, 5, 6, 6. And C cross C. After that, we have to put intersection of both these. And we have to show that both are same. After putting A cross A, B cross B, and C cross C, you have to then intersect B cross B and C cross C, get the answer, and prove that both A cross A and the LHS and RHS are equal. Right? That's what we have to do here. See, A, B, C, and D. What we have to check? Check if show that is it will definitely be equal. Check whether A intersection C cross B intersection B equal to A cross B intersection C cross D. First, we have to complete these two. Complete these two and put intersection. Put it as equation 1. LHS equal to. All right. First, we have to find this two separately. After completing it, put cross section, cross for it. It will be giving a Cartesian product of this two. That will be equation 1. Then here A cross B, 1, 2, 1, 3, 1, 5, 2, 2, 2, 3, 2, 5, 3, 2, 3, 3, 3, 5. C cross D, 3, 1, 3, 1, 3, 3, 3, 5, 4, 1, 4, 3, 4, 5. And automatically you would be getting the result. Check whether it's true or not. If it's not equal, one by one we have to check 1 and 2. If the first term itself is not equal, you don't have to check the other term. No, this is not true. If 1 is equal, already we got this. Okay, go for the second one, go for the third one. If all the terms of both the sets are equal, then we can say that this is true, or else it's not true. Here, whole number x lesser than 2. What is A? Good. Here, natural number greater than 1 and lesser than or equal to 4. 2, 3, 4. This is B. Then C already given. For the given data, we have to find each and every part. First, write this one. What and all we need? B union C, we need A cross B and A cross C. First, complete that. Then put LHS equal to A cross B union C. Since you already got the result, proceed with it. Right? You want me to do this, sir? Or you can complete it. Good. Well done. 7th. The last sum. So, A. The set of all natural number less than A. So, A is 1, 2, 3, 4, 5, 6, 7. Okay. We ourselves will get confused. 5, 6, 7. B is set of all prime number less than 8. B would be
5 and 7.
Good. C is set of even prime number. Good. C is when you apply this, you would be getting the desired result. Apply each and every concept, you'll be getting the desired result. All right. I want you to work on all the examples and exercise of these questions. All right. You should not forego any question. Whether there is an illustration, you have to proceed. If there is no illustration, you have to proceed. Anyway, you have to proceed. We have to work on everything. This is going to be your guide, right? This is going to be your guide. So what and all I'm going to do for you is, from this question, we have a lot of illustrations and examples, isn't it? I'm going to combine all the illustrations, examples together. Whichever illustration, okay, we got illustration 1, isn't it? In illustration 1, we went through this. I'll put this as the first one. You have to put your own data for these. C, carrot, B, or L. It's your choice. Then apple, and form your own pairs. Then illustration 2 help you with A cross B and B cross B. After this illustration, there will be an example which should be related to this, and exercise we have 2 subs. So we will group everything together. Right? So when we group all these things together, it will be illustration 1. It is separate. Then illustration 2, example 1, and in exercise, the first sub, where we always will be finding A cross B and B cross A. And there may be question like A cross A, find A cross A also. All right, all this together. Then we'll be going to the next set. In the next set, we'll be proceeding with these. There was one question here. Here they are given A cross B, and there which one you slightly missed, B cross A. From that we have to find the desired requirement. Then example 3. Example 3 is related with the exercise. So when we group all the exercises and illustrations example together, it would be like 4 sets. The first set will help you to work on A cross B alone, all the pair. You will become fast. The second set will help you to form the number of terms and the required question. The third set, you have to first form the sets. Then from the sets, you have to apply in the desired systematic rules, laws. These are known as laws. It's also known as De Morgan's laws of Cartesian product. All right. It's not here, but it is known as De Morgan's law for Cartesian products. All right. So when we combine it, this first exercise itself will be the combination of a set of rules, set of understandings. Right? See, we can easily answer everything. Then, what is a relation? What is relation according to you? In a not mathematical term, in general term, what is relation? Family members? Blood relations. Person related to us. All right. Okay. Like our chief minister is Mukostal. We are related to him. All right. He is the representative of the whole state. Our prime minister is Mr. Narendra Modi. All right. He is representing the whole country. We are related to him with prime minister. Each and every citizen is related. All right. Then consider your class, your family, yourself and your brother, yourself and mom, yourself and dad, your mom and dad, your mom and yourself, your mom and brother. So there is a systematic series of relations. Then all other blood relations. Okay? Relation is something where we can equate to oneself. There would be a systematic position and question mark for that relation. Right? The same thing happens with here. The way you read will give you a greater knowledge. Right? Many day-to-day occurrence involves two objects that are connected with each other by some rule of correspondence. We see that the two objects are related under the specified rule. How shall we represent it? Here are some examples. New Delhi is the capital of India. New Delhi related with India. New Delhi and India is an ordered pair. Line AB is perpendicular to line XY. That is, line AB is perpendicular to line XY. This is AB, this is XY. This is XY. How they are related? They are related by angle 90 degree, perpendicular to. How they are related? These two lines, angle 90 degree. Minus pi is greater than, minus 1 is greater than plus minus pi. All right, minus 1 is greater than minus pi. Is this true or not? A lot of people would be telling vice versa, because here it is 1, here it is 5. Negative value, when the negative proceeds, automatically it will become lesser and lesser and lesser. But a lot of people won't be considering that one. Okay? Very good. So minus 1 is related to minus 5. So minus 1, 5. L is a line of symmetry of PQR. Line of symmetry. What is line of symmetry?
Symmetry is the where we divide a shape.
Okay. If this is a triangle, if I have a line of symmetry, it means that it can cut into exact two equal arcs. All right. They are told that L is a line of symmetry. So it means that both these are half arc, which can be separated into two. So L is related to triangle PQR. PQR. All right. How are New Delhi and India related? We may expect the response. New Delhi is the capital of India, but there are several ways in which New Delhi and India are related. Here are some possible answers. New Delhi is the capital of India. New Delhi is the northern part of, is in the northern part of India. Delhi is the one of the largest cities in India. So we wish to specify particular relation providing only one ordered pair. See here, exactly New Delhi and India itself can be related in obtain number of ways. Obtain is any number. It's like infinity. We can easily relate with relate anything with India, New Delhi. Right? So we can easily likewise this also line AB, line XY. It can be related by any way. Line AB and line XY are parallel. They will not connect at all. Line AB and line XY intersect. Line AB and line XY are perpendicular. Line AB and line XY are same line. Same line. Same line. All right. Like this, we can relate to any number of questions. So we have to be specific what it is. Likewise, New Delhi, India, it may not be practically helpful. We, as the relation in the following set of ordered pair. New Delhi, India. Okay. What is Washington and USA? It is capital of USA. Washington DC is capital of USA. Beijing is capital of China. London is capital of UK. Kathmandu is capital of Nepal. Right? So let's check the probabilities. A equal to 1, 2, 3, 4 and B equal to A, B, C. Which of the following relations from A to B? A to B. All right. It should be related from A to B. 1B, 1B, 1C, 3A, 4B. All right. It is A to B. So all the first coordinate are from A. All right. But check that here one is related with B and one is also related with C. There can be relation, right? There can be relation. New Delhi, capital of India, New Delhi. New Delhi, Northern India, New Delhi, India. Both are famous. There can be relation. One can be related to C also. It's not a problem. One can be related with C also. Definitely, it's not a problem. But 1A, good, A to B. B to 4. It is not A to B, isn't it? So this one is not. Here, 1A, good. This one is A to 1. This is not relation from A to B. All right. So only this one is right. All right. Only this one is right. Understanding the fundamental theoretically will help you to answer any kind of question. We are not working only for 10th. This will be applied for your 11th mathematics too. You're going to apply all this concept in 11th mathematics too. Same way, B to A, C to A. No, this is B to B, isn't it? This is not the answer. First itself, we found out. Then C to 1, okay. C to 2, okay. C to 3 is okay. C to 4 is okay. Good. Then A to 4, okay. B to 3, okay. C to 2, okay. So these are fine. So when we check into the result, we will definitely get the answers. Definitely get the answers. Okay. Then illustration 4. Students in your class. All right. 4.5, 5.2, 5, 4.5, 5, 5.1, 5.2, 5.5, 4.7, 4.9. All right. So check here. In this set, we have 4.5. We have two 5.2. All right. Two 5s. We are just getting all the heights and we are relating with students. So they are done only for 10 students. We can do for any number of students, even for your class, right? Automatically, some would be of same height. So 4.5 is related to S1, student 1. Again, 4.5 is related to student 4, right? Then 5.2 is related with student 3, all right? Then student 3, okay, first complete the student 3, student 4, 4.5, okay, 4.5 is related to, already we done this. Then 5 is related to S5. Then 6, 5.1. 5.1 is related to 6. Then 7, 5.2. 5.2 is related with 7. Already we have done it for 2 also. One by one, when we go, it will be easy. You won't be missing anything. 10 lines will be related from here to here. All right. This is relation. So by definition, let A and B be any two non-empty sets. A, relation R from A to B is a subset of A cross B, satisfying some specified condition. Some specified condition it should satisfy. X element of A is related to Y element of B through R. That is relation. This is known as relation. This line represents the relation R. All right, through R. Then we can write X related to Y. X related to Y if and only if X comma Y element of R. All right, X comma Y element of R. So in this, the domain of the relation R, codomain of the relation R, range of the relation, right? Okay, what is a domain? A is the domain to which it is related. This is known as codomain. This is known as codomain, right? What is a domain? All the elements which is getting related from set A. Related from set A is the domain. See here, 5 is not related here at all. So 1, 2, 3, 4 is the domain. All right. Then what is codomain? All the elements which are related from A is known as codomain. All right. If I have here Rahul and he is not related at all, so this is the codomain. And automatically what R is related, it is also the range. Range equal to Mati, Arul and John in this case, and it is also equal to the codomain. Note that domain of R is a proper subset of A. It should be, domain will be a proper subset. We can't add, there is no 6 here. We can't add 6 as a domain, right? It should be a proper subset of that. We should not go elsewhere. If A and B are related, I'm relating one to Rohit, which is not in B at all. So A and B are not related. Both the sets, if even one is not related, we can't work with relation at all, right? Relation will help you to understand a lot of facts and theories. Okay, activity, good. Let A and B be the set of lines in XY plane such that A consists of lines parallel to x-axis for x element of A and y element of B. Let R be the relation from A to B defined by x relation y. If x is perpendicular to y, find the elements of B using the graph sheet. A lot of schools won't be working on this at all. Don't worry, definitely you have to work on it, right? Go to the next page itself for this. We have to put a graph sheet also here. These are shortcuts for screen share. Okay, check this question. Let A and B be the set of lines in x comma y. A consists of lines parallel to x-axis for x element of A, y element of B. Let R be the relation from A to B defined by R x related with y if x is perpendicular to y. Okay. What is A? Parallel to x-axis. Any line parallel to, what is the equation for x-axis? What is the equation for x-axis? That is k. All right, that is k. We have equation of line as x plus y equal to 1. You came across this? Set of linear equation x plus y equal to 2, x minus y equal to 4. No? Definitely you would have got this in algebra. All right. This represents a line. All right. You are familiar with the points now. If x equal to 1, then x equal to 1, this is the line which is x equal to 1. Then if x equal to minus 5 is here. This is x equal to minus 5 line, right? Then x equal to plus 6. X equal to plus 6. X equal to plus 6. This is the line x equal to plus 6. So when we check that, this line is parallel to y-axis. The equation of this line is x equal to 1. This is x equal to 6. This is x equal to minus 5. So x equal to 0 would be this line, y-axis. So the equation of y-axis is x equal to 0. This is the equation of y-axis. Similarly, the equation of y equal to 1, y equal to 2 would be like, that is the line which is parallel to x-axis. Let's check. I'm going to draw a line y equal to 3. So y equal to 3. Y equal to 3. All right, y equal to 3. It should be exactly at this point. Y equal to 3. All right, then y equal to minus 3. Y equal to minus 3. All right, this is y equal to plus 3. This is y equal to minus 3. We can easily see that the equation of x-axis would be y equal to 0. And the line which is parallel to x-axis is y equal to k. All right, it can take any number. Y equal to 1, y equal to 10, y equal to minus 100. It doesn't matter. It will be y equal to k. All right. So the line which is parallel to y-axis would be x equal to k. Any constant, x equal to k or a. That's your choice. All right. So from a question, are we in relation with a to b defined by x related to y? If x is perpendicular to y, we know that a consists of lines parallel to x-axis. So what is a? Parallel to x-axis. These two lines are parallel to x-axis. So automatically these are the lines parallel to x-axis. Likewise, we can write y equal to 1, y equal to 2, anything. It's not a problem, right? Then the second condition they have given us, x is perpendicular to y. So automatically you can see that the lines x equal to minus 5, y equal to 1, x equal to 1, x equal to 0, and x equal to 6 is perpendicular to the given lines. All right, that's the relation we have got. If we consider this x equal to 1 and y equal to 3, the relation is 1, 3. The relation is 1, 3. X equal to 1 is related with y equal to 3. All right. So this is the graph they are asking you to draw. All right. Got it? So check it. It is very, very simple. When you understand the fundamental, it will be easy. Okay. Let A equal to 1, 3, 5, 7, B equal to 4, 8. If R is a relation defined by S less than from A to B, then 1 related to 4. 1 is less than 4. All right. 3 is less than 4. But 5 is not less than 4. 7 is not less than 4. So we can't take that. 1 is less than 4. 3 is less than 4. We can take that one. 1 is less than 4. 1 is less than 8. Yeah. 3 is less than 4. 3 is less than 8. Okay. 5 is not less than 4. So we can take that. 5 is less than 8. 7 is also less than 8. So See here, the relation between, they are given that 1 is less than given. First, in first exercise, we went through all the ordered pairs, whatever pair we can give. From that pair, now we are relating to some other pairs with a set of rules, less than or greater than, right? If I ask for greater than, then 5 is greater than 4, 7 is greater than 4. Both will be the choice. Other things are not greater than this. Right? So when you simplify the fact, you'd be getting the desired result. A cross B, we would be getting all the sets. But the R which we got is the subset of this A cross B. The relation which we defined is the subset, definitely a subset of this. All right, definitely a subset of this. That's what they are trying to answer. Illustration 7. What is an arrow diagram? All right. In a particular area of town, let us consider 10 families A, B, C, D, E, F, G, H, I, and J with 2 children. Among these families, B, F, I have 2 girls. D, G, F have 1 boy and 1 girl. The remaining have 2 boys. Let us define a relation R by X related to Y, where X denoted the number of boys and Y denote the family with X number of boys. So we can say that if there are 2 girls, there is no boys, 0. If there is 1 boy and 1 girl, there is only 1 boy, like our family. All right, 1 girl. Then 2 boys, no girls. All right. So we have to define each and every one. See here, among these families, B, F, and I have 2 girls. That is 0 boys. B, F, I. Then D, G, and F have 1 boy and 1 girl. So 1 boy, D, G, and J. Then remaining have 2 boys. So whichever it is not mapped, they have 2 boys. So A is not mapped, C is not mapped, E and H. This is not getting mapped, so they are ordered. See, they have related to some sequence, unsequence. So here, the third rule they didn't give at all. It obviously means that they have 2 boys, right? 2 boys. That's the relation. And this is the arrow diagram. Right? We can easily pair it as 0, 0, B, 0, F, 0, I, okay, I. 1, D, 1, G, 1, J. 2, A, 2, C, 2, E, 2, H. All right. From the diagram, we can easily move to the next one. Since the domain of the relation R is concerned about the number of boys, and we are considering families with 2 children, the domain R will consist of 3 elements, 0, 1, 2, and 0, 1, 2, where 0 represent no boys, 1 represent 1 boy, and 2 represent 2 boys. We note that families with 2 girls are the ones with no boys. Hence, the relation R is given by 0B. We have already done this. Okay. Then the next one. Let A equal to 3, 4, 7, 8. B equal to 1, 7, 10. Which of the following set are relation for A to B? Right? Relation for A to B. First, 3 to 7, 4 to 7, 7 to 10, 8 to 1. Okay. Then, so everything is getting mapped. This is relation. Next, 3 to 1, 4 to 12. 12 is not here, so this one is not. Then 3 to 7, 4 to 10, 7 to 7, yeah, 7 to 7, 7 to 8. 8 is not here. 11 is also not here. But here itself we found that this is not the subset of A cross B. So automatically we are crossing both this, right? Note, a relation may be represented algebraically either by the Rooster method or by set builder method. What is Rooster? What is set builder?
Set builder method is like x is to x. X is to x is a set of
okay.
And the Rooster form is A, comma B, comma C, comma B.
Okay, they will be giving the exact data, prime numbers less than 10, prime numbers less than 8, right? Okay, it will be given in set builder form. Here we have to form the set. Here we have to form the set. All right, we have to form the set by applying this formula. If I apply 5 here, 5 minus 2 is 3. 5 minus 2 is 3. If I apply 6 here, 6 minus 2 is 4. If I apply 7 here, 7 minus 2 is 5. If I apply 8, 8 minus 2 is 6. 6 is not here, so it's not related. Right? So it's not related. Rooster form, set of 5, 3, 6, 4, 7, 5. Domain. What is the domain? 5, 6, 7 is the domain. Range 3, 4, 5. That's range of codomain. Both are same. Range of codomain. Okay. If n of A equal to P, n of B equal to Q, then the total number of relation existed from A to B. See here, all the existing relation 5 to 3, 5 to 4, 5 to 5, 6 to 3, 6 to 4, 6 to 5, 7 to 3, 7 to 4, 7 to 5. It is given by the relation 2 power PQ. 2 power PQ. All right, 2 power PQ. Check what is null relation. The number which we got when we put 8 here is not related in B at all. So this is null reaction. No element is called null reaction. Right? No element is called null reaction. So let's check. The maximum number of relations we can create is if this n is 4 and this is 3, it is 2 power 3 into 4 into 3, 12. What is 2 power 12? 2 power 12 is at least until 2 power 10 you have to know. All right, 2 power 10 is 24. All right, 2 cube is 8. All right, 2 cube is 8. 2 power 6 is 64. All right. Likewise, you can easily equate it. 2 power 6, 2 power 7, 2 power 8. 2 power 10 is 1024. So power 11, doubling it, 2048. Again, doubling 4096. All right. So 4096 combination can be done for this. Maximum number of combinations. All right. That's what they are given. These are all important 1-mark questions. All right. Important 1-mark questions. Okay. Here, again, likewise, we have to combine both together. What I told you. A, 1, 2, 3, 7. B, 3, 0, minus 1, 7. relation A to B. Remember this, check this properly. Sometime they would be giving it as B to A. A lot of people will check A to B and this is wrong, right? So A to B, 1 to 1, 2 to 1, not there, wrong. Then minus 1 is not here at all. This is also wrong. 2 to minus 1, okay. 7 to 7, okay. 1 to 3, okay. This is right. 7 to minus 1, okay. 0 is not here. All right. So this is the right answer. A equal to 1 to 45. Good. RB relation defined by the square of the number. Square of the number. Write the subset of A cross A. Square of the number. 1 square is 1. 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 49. But we have only till 45. So until 6 square it is possible. So what would be the domain? Domain would be only 1, 2, 3, 4, 5, 6. What would be the range? No. To the number which is related. 1, 4, 9, 16, 25 and 36. That would be the domain and also the range. Right? Another number also can be related in some ways. Another number is also related with some ways. But we have to specifically see the result. So what is set A is different, set B is different. Domain is whatever related from this to A. A is 1 to 45. We can relate only 1 to 6 to the next A by square. What is the domain? The numbers or elements which are related. Elements which are related. So now you got the result. Good. It's good you done that mistake, because while you're working the sum, you won't be having any problem, right? Okay. Then third question. A relation R is given by set y equal to x plus 3. Element 0, 1, 2, 3, 4, 5. Y equal to x plus 3. Determine its domain and range. Domain and range. Y equal to x plus 3. Only R is given, R to R. Only one set is given, right? When I substitute, okay, the first one would be 0, 1, 2, 3, 4, 5. Good. Right? And the second one would be same, 0, 1, 2, 3, 4, 5. All right. Y equal to x plus 3. So when I put x equal to 0, 0 plus 3 is 3. Yeah, I got one. Good. Then when I substitute 1, 4. Yeah, I have 4. Good. Then if I substitute 2, 5, I got 5. Right? 5. If I substitute 4, I'm getting, if I substitute 3 itself, I'm getting 6, which is not here. So after that, after 3, we won't be getting any answer. So the domain is 0, 1, 2. The codomain and range is 3, 4, 5. Right? Okay. Represent by arrow diagram a graph, a set in rooster form, wherever possible. Wherever possible. Right? Okay. Element 2, 3, 4, 5. Given by x equal to 2y. Relation is x equal to 2y. Okay. If I substitute 2 into 2, 4. Yeah, I have. If I substitute 3, it would become 6. It's not there. Only one is getting related. Right? Oh, sorry. We have y also here. Here they just given r. We have two sets here, x and y. X and y. X is related to y by 2y. All right. So if I substitute 2, what I will get? 4. If I substitute 3,
6.
okay.
And
Place of y you substitute. Substitute the place of y. If I substitute y equal to 1, it is 2. If it's 2, 4. If it's 3, it's not here. So we can't map at all. So we can map 1 and 2 with 2 and 4. What is the domain? What is the codomain? And set 1, 2 and 2, 4. This is the roster form. All right. Then arrow for the diagram 1, 2, 3, 4. All right. Put the diagram 1, 2, 3, 4 and 1, 2, 3. And which one is related? 1, 2 is related. Put that point. 1, 2 and 2, 4. We'll be getting this. Then here, x and y both are natural number less than 10. Both are natural number less than 10. So x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Y is also same. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then applying y equal to x plus 3. When I substitute x equal to 1, y equal to 4. Then 2, 5, 6, 7, 8, 9. Until 8 we can get. For 9, sorry, and not until 8. If I substitute 1, we will be getting 4. 1 to 4, 2 to 5, 3 to 6, 4 to 7, 5 to 8, 6 to 9. After that, we won't be getting. So that will be the arrow diagram for it. In arrow diagram, we will be substituting all the values in x and y. But while relating 1 to 3, 1 to 4, 2 to 6, sorry, 2 to 5, 3 to 6, 4 to 7. In arrow diagram, then in graph. All right. This looks like a very big sum, but that's not so. All right. It may look like a big sum. We can easily segregate everything. Right. A company has 4 categories of employees given by assistant A, clerk C, manager M, and an executive officer E. Is the highest, then the manager, then the clerk, then the assistant. Executive will be having 10 managers. Each manager will be having 10 clerks. Each clerk will be having 10 assistants. So from they will be doing the work. They will report to that respective clerk. All the 10 clerks report to one manager. All the 10 managers report to one executive. That's how a big company is formed. Right? The company provides 10,000, 25,000, 50,000, and 1 lakh as salaries to people who work in their categories. 10, 25, 50, and 1 lakh. A, C, M, and E respectively. Okay. Assistant, clerk, manager, executive. If A1, A2, A3, A4, A5 are assistant. C1, C2, C3, C4 are clerks. M1, M2, M3 are managers. E1, E2 were executive. And if the relation R is defined by X related to Y, where X is the salary of the given to the person, Y is the expression through the ordered pair. Ordered pair. So how this question would be? It may look big, but in reality, it is nothing. This is the question which is being asked to you. X is the salary. All right, X is the salary. Then Y is the employees. All right. So right, we have 10,000, 25,000, 50, and 1 lakh. Right? We have to write it fully. So I can delete this and put a bigger ellipse. So that it will accommodate that 10,000, 25,000, and so on. So each color 10,000, 25,000, 50,000, 1 lakh. Okay? 1 lakh. Here A1, A2, A5. A1, A2, A3, A4, A5. Then C1, C2, C3, C4. C1, C2, C3, C4. Then M1, M2, M3. M1, M2, M3. Then E1, E2. Right? So 10,000. We have 10,000. 1, 2, 3, 4, 5. Then 25,000. Red. 1, 2, 3, 4. Then 50,000 dark green. 1, 2, 3. Then 1 lakh. 1. Right? So this is how it would be. Here we have to write X related to Y relation salary. Right? Salary. Automatically it will get into. So your chapters are simple when you understand. If you don't understand, it will be difficult. Right? How is the class? How you feel about it? We have completed 2 exercises. Right? How do you feel about the class? Okay. If you want me to improvise something in between, right? Improvisation which I want you to do for your own, how to say, if you want to move beyond that centum mark, a lot of people would be working for centum. If you want to move beyond like this, you can create your own question, like pencils or foots or heights. Like this, you can create your own theoretical question. You have to relate everything by yourself. Okay. A pencil is 5 rupees. A scale is 5 rupees. A pen is 10 rupees. A chocolate is 10 rupees. Another chocolate is 5 rupees. Like that, you can relate different items also, and you can create your own sum. I want you to create at least one sum. At least. It means your growth can be determined by yourself. How many examples you want to create, you can create. The result would be, if you create many more examples like this, automatically the way you see mathematics and science relate everything, science, maths, and everything, and get as many examples as possible. Minimum of one examples like this, any relation. It doesn't have to be big sum like this, right? It may be like trees, which has simple leaf and compound leaf. That is also simple leaf is only one leaf, like hibiscus. Compound leaf, neem. While you're traveling, you're looking at different trees. One tree is having a simple leaf, only one leaf, simple leaf. One is having compound leaf, like neem. Neem, that one single stalk would be having small leaves, isn't it? Actually, that is known as compound leaf. The whole one thing is leaf. It has one. A hibiscus is a simple leaf, right? A sawtooth simple leaf. A neem is a compound leaf. A neem is a compound leaf. Neem is a compound leaf. There are different types. You can relate simple and compound leaves while you're going. Okay, you saw 4 trees, 4 or 10 or 20 trees. Like that, you can easily relate with science, mathematics, and English, physics too. For example, you're taking a paragraph. You're taking paragraph and selecting the words. How many words are there? You're just selecting how many letters are there in each word. You'll be having 1-letter word, 2-letter word, 3-letter word, 4, 5, and 6. So you can relate, okay, first word, second word, third word, fourth word. Like that, there will be up to number of relations. The way you work will enhance your skill set. Enhance your skill set. That's what I want you to do. Minimum 1, maximum sky is your limit. Right? Sky is your limit. Make it simple as possible. Okay. So now we went through relation assumption. First, we went through ordered types, Cartesian products. Then from Cartesian product, we went into relation, where we cut short some products by giving some relation to the given data. Now the function is something more into relation. All right. What is this is really important. The people who are not, even though they take mathematics as a group in their college, they are not really strong because of these fundamental things. They are not strong in the theory. So they can't understand the theories, because there they will be learning a lot of theories and problems. Application and how we derive the formulas and everything. That's what they'll be doing in the BSc Mathematics and MSc Mathematics and PhD. All right. There, because they are not strong in theories, they are losing scores. One who got centum in 10th standard, if around 1,000 people are getting centum in 10th standard, out of them, we may expect 1/4, 250 to get. That is very, very optimistic thinking. 1/4, 250 will be getting centum in 12. That itself is really optimistic. 100 out of 1,000 who got centum, 100 itself is a big ask for 12th standard. Right? And when you go into from that 100, when the people who are going to BSc Mathematics, only around 10% will be surviving the next stage. They love mathematics in 10th, 12th, but they will hate mathematics in BSc. And in that also, there also they have done well. They have put the efforts and done well. If they try to do MSc Mathematics, it is totally different. It will be more difficult for BSc graduate itself. It's like out of 100 people who are opting for MSc Mathematics in the first year, while they are going to second year, not even 50% of people will be there in the class. They can't survive, and most of them will be leaving in between. That's the reality. So what would be the case of PhD? It is just filtering from 10th to 12th to BSc to MSc to PhD. Everything it will be filtered with smaller sleeve. Just like that, functions, right? Among several relations that exist between two non-empty sets, some special relations are important for further exploration. Such a relation is called functions. Some special relationship. Illustration. Do you want to break that? Are you sure?
Yes.
Are you sure?
Yes.
Because when I'm teaching mathematics, I'll be in a different zone. Right? The way I spoke to you yesterday will be totally different what I'm doing now. Okay? Because I will forget everything when I'm teaching mathematics. I'll proceed on and on. How much time you are ready to listen to me, I'll be moving on now. Right? You're okay with it? All right. A company has 5 employees in different categories, namely E1, E2, E3, E4, and E5, and the salaries. Right? If we consider the salary distribution for a month as shown in arrow diagram 1.11, we see that there is only one salary associated with every employee of the company. There is no 2 salary associated, isn't it? Only one will be associated with every salary. All right. This employee won't be getting 20,000 and again 30,000. Here are the various life situation illustrations, some special relations. Consider the set A of all your classmates. Corresponding to each student, there is only one age. You cannot be 14. You can have people, students who are 14, 15, maximum 16 in your class. Okay. It can't be less than 13. It is not eligible for 10 at all. So 14, 15, and 16 may be your class group. So one student will be related to one age only. You can't be related to age 13 and age 14 or age 15. So only one relation is possible from set A to set B. All right. If you go to shop to buy a book, if you take out a book, there is only one price corresponding to it. It does not have 2 prices corresponding to it. Of course, many books may have the same price. Many books may have the same price, but each and every book would be having only one price. Right? This book also can be 100. This book also can be 100. But one book will not have 2 prices. Right? So here too, only one should be associated with the other. All right. 1 to many or 1 to 1. All right. You'd be coming across those things. Examples. These are examples. You are aware of Boyle's law? Are you aware of Boyle's law? What does Boyle's law say? Yeah, definitely. Understand this. Mathematics is the tool of science. All right. We are learning this mathematics because we have to understand science. If you understand science only, you can proceed. All right. Whenever there is a pattern or relation between something, we are trying to learn that. That is known as science. Right? We are trying to decode the pattern which they are provided in 10 mathematics now. But we are coming across science too. In science too, we will be coming across a lot of mathematical formulas, relation, multiplications. In higher classes, physics or chemistry, if you take physics or chemistry in your 11th grade, definitely you have to work on it. Specifically, you have to work on it. Right? So what does Boyle's law say? Boyle's law say PV equal to RT. All right. Under standard temperature, constant temperature, pressure is directly proportional to volume. Sorry, indirectly proportional to volume. That is P indirectly proportional to volume. All right. If the volume increase, it means that if volume increase, pressure decreases. If pressure increase, volume decreases. Consider a balloon. Consider a balloon. All right, a balloon, hanging balloon. If I constrict this volume, pressure will be increased. If I release it, pressure will be decreasing. All right, that is Boyle's law. Definitely, you have to know all these things. All right, then this is related with economy. We will be having economy lesson in sociology. Right? In economics, the quantity demanded can be expressed as Q equal to 360 minus 4P, where P is the price. 360 is the fixed cost. Fixed cost, P is the price. There should be a relation how much quantity we can make to obtain maximum profit. All right. So 360 is the fixed and minus 4P is the relation they have given, where P is the price of the commodity. We see that in each value of P, there is only one value of Q. If I put P equal to 2, price equal to 2 rupees, then 360 minus 8, quantity which I can produce is 352. If I fix the price as 10, 4 into 10, 40. So I can produce only 320 quantity. So this is the relation between the quantity which I have to make and the price which I'm going to fix. All right. There is a lot of difference between cost and price. We say cost of this pen is 10 rupees, 20 rupees. All right. But we say colloquially as a common people. But when we see the cost which we pay, it will be given as price. That to MRP, maximum retail price. What is maximum retail price? Then what is cost?
Cost is what we use from.
No, actually, cost is the amount which I spend for making that product. I'm getting raw material for 10 rupees. I'm giving 2 rupees salary to a person and making him work on that raw material, skilled worker, 12 rupees. I'm using packing for 1 minute, 14 rupees. So the cost of that product is 14 rupees. The price which I would be selling is 20 rupees. So the profit is price minus cost. Cost is the amount, the capital which is required to make that product. One complete product is known as cost. If I'm getting a printer machine for me, number one, that printer machine I'm getting in second hand, 8,000 rupees, and spending 2,000 rupees, on repair, give service to them. So the total cost is 10,000. 10,000. The total cost I'm spent on that is 10,000. I repaired it and sold it for 12,000. The price which I'm selling is 12,000. So what I did there, I took a product, serviced it, and cleared everything and sold it for 12,000. This is what a company does. Get product from someone, get different raw material, put everything together and sell it as a new stock, different stock. That's what we have to do. So why I'm strong in business? Because I teach English, physics, chemistry, mathematics, accountancy, economy, psychology, sociology. I teach everything. That's why I could easily relate everything to. So I can relate mathematics, statistics with physics, chemistry, even in English. I used to apply some mathematical concept and help them imagine just how you can put this equation in words. 3x plus 5. Like that, I can easily relate everything together to help them. When you think about this, you'll be getting the result. Right? So, see here, there is a particular function, and only for each price, there will be simple quantity. We won't be having different quantity for same price. Right? So, we often come across certain relationship in which for each element of set A, there is only one corresponding element of set B. Such a relation is called function. We usually use the symbol F to denote the functional relation. Definition. All right. So what is a function? What is the function? Two sets. Each and every element of set A should be related to only one element of set B. Right? One element of set B. So until now, what and all in the first exercise, we came across Cartesian Product. In the second exercise, we went across relation. Now, in relation itself, we are taking care of one particular set known as function. So, function is inside relation, relation is inside Cartesian product. Right? That's what we are moving into. It is a systematic process. What you're learning is systematic process. That's why I'm not directly going into sum. We have to understand the concept, where and all it is applied, and we have to proceed with the next one. If you're writing TET exam, you want to become a teacher, isn't it? We have to write a specific exam, TET exam for that. Right? Or NET exam for you to teach in a college. If you have cleared that, you'd be getting a very good salary. Very good salary. A normal lecturer in a school or a normal teacher in a school, they may get 10,000 rupees as salary. The person who have cleared the TET and scored good score on that would be getting more than 40,000 salary. That's the difference. And if you're working in a government institute, if you've got a really good score, you're working in a government school, you'll be getting more than 80,000 as a salary. If you're teaching 11th and 12th, you'll be getting salary of more than 1 lakh. It will be good, isn't it? Only 10 months will be working. In that too, each day, you will be having only 2 hours of class. Other hours you can prepare. If there are around 8 periods in a school, maximum you would be taking 4 hours. Or 2 to 3 hours only you would be taking. Saturday, Sunday, holidays, and annual holidays. It would be great. Teaching is a great profession. But we have to understand. For each and every example, I can easily relate with things. You can see that I can easily relate with things and give more examples of it. When you work on creating more examples, automatically you'll be getting the desired result. Right? So, a relation F between two non-empty set X and Y is called function from X to Y for each X element of X. It should be related from each of X. There should be a relation. If there is no relation with E, then it's not a function at all. In relation, we had that x plus 3. For 7, we got 10. It's not possible. But in function, every element of set A should be mapped to only one element of set B. It can be all the element can be pointing to only one element also. It's not a problem. But it has to be pointing. All right? That we have to understand. Okay? Good. Now you understand, ma? Understood now? There exists only one element of y. For every element of x, there should be only one element of y. That is known as functions. Right? A function f from x to y is written as f from x to y. F for from will be putting colon x to y. Comparing the definitions of relation and function, we see that every function is a relation. Thus, functions are subsets of relations, and the relations are subset of Cartesian product. This one we already explained. Right? A function f can be thought as a mechanism or device, fig 1.12b, which gives a unique output f of x to every input. A function is also called as transform, mapping, or transformation. Mapping or transformation. What and all we have to know in function. Good. If f from x to y is the function, then the set x is called the domain. Definitely, we saw that domain is whatever is getting mapped in a relation is domain. But in function, we know that x, all the element of x should be mapped. So the x itself is a domain, right? And y is called as codomain. The set y is called the codomain. Right? Then if f of b equal to f of a equal to b, then b is the image of a under f, and a is the pre-image of b. I will show the example here. In this function, image of E1 is 1 lakh. Pre-image of 1 lakh is E1. Image of E1 is 1 lakh. Pre-image of 1 lakh is E1. Okay? Right? Image of E1 is 1 lakh. Pre-image of E1 is pre-image of 1 lakh is E1. All right? The set of all images of the element x is called range. So, in a function, one, two, three, four, five. A, B, C, D, E. X is known as domain. Y is known as codomain, fully codomain. Right? Then relation 1 to B, 2 to A, 3 to B, 3 to B, 4 to E, 5 to B. Right? 5 to B. So all is mapped. All is mapped. Here, what all it is mapped to? What all it is mapped to? B and E. This is the range. This is codomain. This is codomain. Range is what all element mapped in Y. B and D. B and E. B and E is the range. Right? B and E is the range. So that's what we found here. Range. F from x to y is a function only if every element is the domain of f as an image. We already know that for every element of x, definitely it should have an image. So the image is unique for each and every one. Right? Image, for that, it is the image. Not every element of codomain would be having a pre-image. Okay? But every element of x should have an image. If x has A, B, C, this one has 1, 1, 2, 3. So the ordered pair would be A2, A2, B2, C2. A, 2, B, 2, C, 2. It is unique set of ordered pairs. Right? If A and B are finite sets, then n of A equal to P, n of B equal to Q, then the total number of functions that can exist is Q power P. Finite sets. The number of functions which can exist is Q power P. A to B is Q power P. Right? In this chapter, we always consider f to be real valued function. F to be real valued function. Right? F to be real valued function. Describing domain of a function. Let f of x equal to 1 by x plus 1. If x equal to minus 1, f of minus 1, what happens? 1 by minus 1 plus 1. 1 by 0. Anything by 0 is infinity. 0 by anything is 0. But for f of minus 1, this is not defined. So every function has to be defined. We can't have infinity. These are known as indefinite form. 0 by 1 is 0. 0 by 100 is 0. 0 by 0 is an indefinite form. 0 power 0 is also indefinite. 0 power infinity, all these are indefinite forms. 1 by 0 or anything by 0, all these are indefinite forms. There is no value. All right. So it's not defined. Hence, f is defined for all numbers except minus 1. Since f of minus 1 is not defined, for all other numbers, if you put 0 also 1 by 1, we'll be getting a value. If you put 2, 1 by 3, we'll be getting a value. If I put minus 2 plus 1 is minus 1. 1 by minus 1, we'll be getting a value. So apart from minus, all numbers minus 1, minus of set minus 1, we'll be getting the result. Okay. And this, are you familiar with factorization? If you factorize x squared minus 5x plus 6, what will you be getting? Have some guesses. X squared minus 5x plus 6. If I multiply, I have to get plus 6. If I add, I have to get minus 1. So this is plus, this is minus. So both should be negative. Minus into minus gives plus here. Minus minus will be giving 3. You got it. So x minus 2, x minus 2. So x equal to 2, x equal to 3. For that question, for this question, x squared minus 5x plus 6, if you put x equal to 2, this one becomes 0. If you put x equal to 3, again it becomes 0. So apart from those two, it is defined for all real numbers, it will be defined. 1 minute, 1 minute. Papa. For that value alone, x squared minus 5x plus x. For if I put 2 here, this one becomes 0. If I put 3 here, again it becomes 0. That's why our real number except 2 comma. Right? Except 2 comma. So progress. Relations are subset of Cartesian form, Cartesian product. Functions are subset of relations, or functions are subset of relation or Cartesian product. Both is true. All the elements of relation should have image. False. Right? False. Subsets of Cartesian product. Functions are subset of relation or Cartesian product. Cartesian product also right one. All the elements of function should have image. R from A to B is the relation, then the domain R equal to A. Right? R from A to B is a relation, then domain R equal to A. Good. R. Right? Definitely not a function, it's a relation. If it's 1, 2, 3 in relation A, B, C, this is only domain, isn't it? So you have to imagine. That's why we draw a lot of things. We have to imagine. Actually, it is false. There may be some. There may be some which has all the elements as some relation. It doesn't mean that they have to. See here, your family and your school. Right? You and your brother is studying this. Your mom and dad is not studying this. Right? So they can't be related there. This is one set. In this, yourself and your brother can be related, not your mom and dad to the school. The relation is studying in that school. Right? That's different, isn't it? That's why domain not the same. But if it's function, what you told us, right? They are twisted with R here. Right? So if f n to n is defined by f of x equal to x squared, the image of 1 and 2 are n to n, natural number to natural number. So all natural number, no problem. Related by x squared. Image of 1 is 1 square. 1 square is
1.
Image of 2 is 4. They may ask pre-image of 9, pre-image of 16. Okay, then we can easily relate. A lot of people could proceed and write 81, 256. Right? So be careful whether it is image or pre-image. Okay. What's the difference between relation and function?
Relation, domain doesn't have, the domain is not all the components in the set. In the function, domain is the
Okay, number one.
In function, it has the, each and every component has the image, but in relation, it doesn't.
All elements of A should be mapped with at least only with one element of B in function. But in relation, it can be map with anything, provided the relation gets satisfied, right? The relation gets satisfied. So that range, okay, codomain, okay, okay. Only one should be mapped. Then it is a function. Any sets with the provided relation statement, it's okay. For Cartesian, all kind of ordered pairs is Cartesian. So Cartesian is the universal set. Universal set. It contains all the ordered pairs. From that, sum is related. In relation, again, sum is a function. Okay. Let A and B be two non-empty finite sets. Then which one among the following two collections is large? A and B be two non-empty finite sets. Which one among the following two collections is large? Number of relation between A and B, or number of functions between A and B? Number of functions. In the diagram itself, we saw that relation is more and function is inside that. And we came across a formula also. We came across a formula. Remember? That's the formula. P power Q. All right, P power Q. But for relation, the maximum number of relations. Two power PQ. All right, 2 power PQ. That is Q power P. Q power P. 2 power PQ. Right? So that much exists there. That much exists there. Okay. Now you understood now. This one is more, this one is less. Testing for functions. Arrow diagram. Arrow diagram. This represents a function. Each input corresponds to single output. Yeah, each to single output. This is also a function. Represent input correspond to single output. This one is not a function. Right? This one is a function. This one is a function. Good. For here, B has two images. How can we have two images? If you look into a mirror, will you have two images? A devil and an angel. Huh? We can't accept it. We have single image. Just like that, B would be having, can't be having two images. Only one image is possible. So this is not a function. This is not a function. Next. Function plays very important role in the understanding of higher ideas in mathematics. Like I told you, when you are going into ideas, you definitely should have something related. Right? There are basic tools to convert from one form to another form. In this sense, functions are widely applied in engineering sciences. The range of a function is a subset of its codomain. Range, definitely codomain. This is the codomain. Range is always a subset of this codomain. Right? They are basic tools to convert from one form to another form. In this sense, functions are widely applied in engineering sciences. Like I already told you, mathematics is a tool of science. A lot of people think that if I go through physics, chemistry, and biology, I can easily clear NEET. without understanding mathematics, they can't easily clear it at all, because the mathematical functions, rules, and regulations are applied in more than 34% of questions. If you don't understand the question, how do you expect yourself to clear it? Right? So when they think that maths is tough, it's better for them to leave that NEET also. Right? If someone wants to clear NEET, definitely they have to take physics, chemistry, mathematics, and biology, because all the mathematical concepts will be applied in physics and chemistry, and in some cases in biology too. For example, decay constant, decay. They use differentiation and integration to understand the relation and get to the result. Think about this fossil fuel. Fossil fuel. They can easily calculate the year result. They unearth a mummy from a tomb. They can exactly say what time, what year that person died. How is that possible? They use this mathematical tool to calculate it. There is something known as radioactive carbon, carbon C14, right? Carbon C14. This carbon C14 is radioactive, which has half-life time of very good half-life time, around 5,200 years. So if there are 1,000 carbon C14, after 5,200 years, it becomes 500. After another 5,200 years, it becomes from 500, it becomes 2. After another 5,000 years, it will become 170, 125. So it proceeds, goes on and on. By calculating that, they can definitely say this is the time that person died. Even in postmortem and everything, they are going through, isn't it? They are going through the same route. When there was a murder or something, when you watch a movie, how do they calculate at what time the person died? Using this carbon C14 only. Using this carbon C14 only, they will calculate. So maths is related with science. Science is related with maths. It is like without this, physics or chemistry will not be easy. Right? So we have to be strong with mathematics. Next. Now you understand reasons. Okay. X is 1, 2, 3, 4. And Y is 2, 4, 6, 8. Range is 1, 2, 2, 4, 3, 6, 4, 8. Right? They are already given the data. How the functions later and all they didn't give. They're just given the data. Show that R is a function and find its domain, codomain, and range. R 1, 2, 3, 4. Y is 2, 4, 6, 8, 10. But 1 is related to 2. 2 is related to 4. 3 is related to 6. 4 is related to 8. It is simple. 2x. Okay, 2x. 2x. All right, that's what we have got. 2x. So the pictorial representation, arrow diagram, this is known as arrow diagram. R is given by Fig 1.14. From the diagram, we see that X is element of X. There exists only one Y element of Y. Thus, all the elements of X have one image. One image. Therefore, R is a function. Domain X 1, 2, 3, 4. Codomain Y 2, 4, 6, 8, 10. And range only 2, 4, 6, 8. Only 2, 4, 6, 8. Okay. Example 7. Relation is given by x squared minus 2. X is minus 2 minus 1, 0, 3. Why they've given us R? It can take any values from minus infinity to plus infinity. Minus infinity to plus infinity. List the elements of f. Is f a function? That's what they are asking. X squared minus 2 whole square minus 2. 4 minus 2. 2. Then applying minus 1. Minus 1 squared. That's 1. 1 minus 2 is minus 1. 0. It is minus 2. 3. 9 minus 2. 7. 9 minus 2, 7. So minus 2 comma minus 2 comma 2 minus 1 comma minus 1 0 comma 2 3 comma 0 comma minus 0 comma minus 2 3 comma 7. So this is the format. Applying that, we'll be getting the result. Okay, this is the image. Since this is real number, it's not a problem. If they are given it as natural number, we have got 2 negatives, then this is not a function. Right? So that's what we do. We know that each element in domain of f has a unique image. Definitely, it has a unique image, therefore it's a function. Is the relation representing the association between planets and the respective moons a function? What do you think? Relation representation between planet and the respective moons. Why not?
Because there's only one planet, but the planet has many moons. So the image.
Some planets like Jupiter, Mars, everything have many moons, not one moon. So one is getting related to many. It's not a function, right? Function. Planet and their moons is not a function. Since they are given plural, definitely it's not a function. They are not speaking about Earth. They are speaking about moons. Example 8, 1.8. If x equal to minus 5, 1, 3, and 4, y equal to a, b, c, then which of the following relations are functions from x to y? Minus 5, 1, 3, 4. There are only 3, not a function. Minus 5 to b, okay. 1 to b, 3 to a, 4 to c. Okay, this is a function. Okay, this is a function. Yes, this is right. Then minus 5. 1 has 2 image. No, this is not a function. Right? So 1 is a function. Automatically, we can represent it in arrow diagram and say, okay, this is a function. This has second is, but this is not a function. This is a function. This is a function. And this has 2 image, not a function. Right? Not a function. So next, they're given f of x. Find the value for f of 1, f of x plus 1, f of x plus f of 1. All are completely different. When I put x equal to 1, 2 into 1 minus 1 square. 2 into 1 minus 1 square. 2 minus 1. Right? Then if I put x equal to x plus 1, this means at the place of x, we have to substitute x plus 1. So 2 into x plus 1 minus x plus 1 whole square. 2 into x, 2x plus 2 minus x square minus 2x minus 1. I am multiplying all the numbers. I am expanding x square plus 2x plus 1 in a plus b whole square formula and multiplying with 1. So f of x plus f of y. If I substitute f of x, it is 2x minus x squared. It will be just same. Plus f of 1. F of 1, we already found out 1. I'll be adding that one up. Okay? That's what we'll be doing in this exercise. X and y. F, x and y, both terms of natural number. So y equal to 2x. Be a relation on n. Find the domain and codomain and the range. Is it real? Is it a relation? Is this relation a function? What do you think? If I put the value of x natural numbers 1, 2, 3, 4 and goes on. 1, 2, 3, 4 and goes on. Right? Then y equal to 2x. 2x also is a natural number. 2 into 1, 2, 4, 6. That is also a natural number. So definitely, if it's related to y to x, yeah, it is a function. For all terms of natural number, there'll be a term for y also. It will be definitely a natural number. There'll not be a negative integer or something. So find the domain. Domain is a natural number, and codomain is even natural number. Even number. Okay. Range also even number. All even number. Is this relation function? Yeah, it is a function. Here x equal to 3, 4, 6, 8. Relation. X, f of x equal to x element of x. X squared plus 1. Function from x to n. Natural number. So 3 squared plus 1. 9 plus 1, 10. 16 plus 1, 17. 36 plus 1, 37. 64 plus 1, 65. X squared plus 1. So domain, okay. What is the range? 10, 17, 37, 65 would be the range. Yeah, this is the function. Okay. It is getting related. Everything is getting one unique solution. Okay. So it's a function. Then when I substitute minus 1, what I would get? 2a, what I would do? Then 2, what they x of minus 1, what they get. Okay. You just have to substitute the value of minus 1. Minus 1 whole square minus 5 into minus 1 plus 6. This is 1 minus into minus plus 5 plus 6. So, if I substitute 2a here, 4a square minus 5 into 2a plus 6. So 4a square minus 10a plus 6. If I substitute 2, 4 minus 10 plus 6, 0. If I substitute x minus 1 whole square minus 5 into x minus 1 plus 6. So x squared plus 1 minus 2x minus 5x plus 5 plus 6. So we have to equate the terms, isn't it? X squared minus 2x minus 5x minus 7x 1 plus 5 plus 6, 12. Right? So this would be the answer. Then a graph representing f of x given in Fig 1.6. It is clear that f of 9 is 2. F of 9 equal to 2. Then find the value of f of 0, f of 0, f of 7, f of 2, and f of 10. For it is not clear, but they are saying that it is clear. For 9, f of 9, the answer is 2. For f of 9, the answer is 2. What will be for f of 0? F of 0, answer is 9. F of 7, answer is 6. F of 7, it is 6. F of 2, 6. F of 10, 0. Simple. For what value of x, f of x is 1? 1. For what value of x, f of x is 1? 9.5. Okay. Describe the following: domain or range. Describe the following: domain. All this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is domain. All right. Range would be for 1, 7.5, for 2, for 3, or for whatever value it takes. That one would be range. What is the image of 6 under F? Image of 6 under F. Image of 6 is 5. If they ask pre-image of 6, then this line, where this line cuts, 2 and okay, 2 and 7. 2 and 7. Okay, or 2 and 7. Right? So this is what the result is. Okay. F of x equal to 2x plus 5. Find the value of f of x plus 2 minus f of 2 by 2. First find f of x plus 2. 2 into x plus 2 plus 5. That is 2x plus 10 plus 2. 2x plus 12. Right? Then applying that, you will be getting the result. Then f of 2 is 2 into 2. 4 plus 5 divided by x. This is x, this is not f of x. First, we have to find this value, subtract this value, and totally divide this value to get the result. Then a function f is defined by f of x, 2x minus 3. Good. Then find f of 0 plus f of 1 by 2. F of 0 is minus 3. F of 1 is 2 minus 3, minus 1. Minus 3 minus 1 is minus 4 divided by 2, minus 2. Okay. For find x such that f of x is 0. If I put 2x minus 3 equal to 0, f of x is 0 they are given. So 2x minus 3 equal to 0. X equal to 3 by 2. Find x such that f of x equal to x. So 2x minus 3 equal to x. And this x goes here, 3 goes here. 2x minus x equal to 3. X equal to 3. F of x equal to f of 1 minus x. F of x, just like that, 2x minus 3 equal to 1 minus x. 2 into 1, 2 minus 2 into minus x, minus 2x plus 3. So 5 minus 2x. 5 minus 2x. Okay. An open box is made from square piece of material 24 centimeters on a side by cutting equal squares from corners and turning upside down as shown. Express the volume function of x. See here, 24. I'm cutting 4 squares. 4 squares. Then what would be? This is x, this is x. So this length would be 24 minus x. When I close this, it will form a box. When I close this, it will form a box. This is also 24 minus x, this length. Both 24 minus x and height is x. So volume of a cuboid is length into breadth into height. So 24 minus 2x into 24 minus 2x into x. 24 minus 2x, 24 minus 2x into x. So this is a minus b whole square. So 24 square. What is 24 square? It is 576. You have to know at least till 25 square. 576 plus b square minus 2x whole square plus 4x square. Next, 2ab minus 2 into 2, 4, 4 into 24, 96x into x. So this one into x. So 576x plus 4x cube minus 96x squared would be the answer. Here also, a lot of people would get confused. F of x squared. In each place of x, we have to substitute x squared. All right. This is f of x whole square. You have to square this number. If both are equal, find x if both are equal. Can we do this sum then? Some questions are really interesting. I'm totally concentrating on CBSEs. I didn't went through this metric, but I will work out all the sums without any worries. Whatever it is, I'll work it out. F of x squared. F of x squared is 3 minus 2 into x squared. That is 3 minus 2x squared. F of x whole square is 3 minus 2x whole square. So 9 minus 2 into 2, 4, 4 into 3, 12x minus, plus b squared, 2 squared, 4, x squared, x squared. This is what they are given. What they are told, these two are equal. So 3 minus 2x squared equal to 9 minus 12x plus 4x squared. If I take these two this way, it will become 4x squared plus 2x squared. I'm putting it in order, okay? Minus 12x plus 9 minus 3. So equal to 0. 6x squared minus 12x plus 6 equal to 0. If I divide by 6, I will be getting x squared minus 2x plus 1 equal to 0. This is x minus 1 whole square equal to 0. So x equal to 1. If you know, if you practice some questions, it will be easy for you. You will be answering immediately. Okay? Or else you have to segregate. One have to get minus 2. So it should be minus 1 into minus 1 into minus 1 plus 1. This is minus 2. Like that, we have to put x minus 1 into x minus 1. Both are same. So x minus 1 equal to 0, x equal to plus 1. Okay. This is how we have to work this out. Then 9th, a plane is flying at a speed of 500 km per hour. Express the distance traveled by the plane function of time and hours. What is speed? Speed equal to distance by time mark. So distance equal to speed into time. Speed into time. So simple, 500 t. That's it. That's what they asked. Nothing much. That's it. 10th one. The data is an adjacent table. This is the length of a person's forehand and the corresponding height. All right, forehand and height. This is in centimeter. This is in inches. Check the unit also. Centimeter. This one, right? This one and my height. All right. So based on this data, a student finds a relation between height, h, and forehand. Length to be ax plus b, where a and b are constants. With these data, a student checked and found that the relation is between this forehand and the height of a person can be related with ax plus b. Check if this relation is a function. Each and every forearm is pointing to one height, isn't it? So it is a function. Find a and b. How to find a and b? Y is the height, x is the length of forearm. First thing we have to do is we have to convert everything in same unit. That is most important. If this is in centimeter, this also should be in centimeter. So how many centimeters? 1 inch. How many centimeter is 1 inch? Centimeter is 1 inch. Good. That's it. Okay, 2.5. So you have 15 centimeter scale is there. It has 6 inches and 15 centimeters. Divided by 6, you'll be getting 2.5. So we have to multiply this with 2.5. So 28 into 5. That is 28 into 2 into 2.5. 56 into 2.5 can be converted into 28 into 2 into 2.5. This can be converted into 5. So 28 into 5 is 140. How to multiply by 5 is half of this number. Any number into 5. Half of that number, 14 into 10. If it's 13.5, half of this is 6.75 into 10, 67.5, 13.5 into 5. Any number, if it has to be multiplied by 5, take half of that number, multiply by 10. Okay. I have an exercise for you regarding these things too. I have created around 30 exercises for this to speed up your mathematics. You should not be, that is good. You have to be fast enough without any errors. Speed should be there, error should not be there. Right? That's what will create you. The speed is good and error is also minimum. You can complete your 2.5 hours paper within 1 hour, 30 minutes. 1 hour you'll be having extra time. That is the importance of mathematics. If you understand it, you can easily be faster. That's up to you. Okay. So to find the relation, then x is 35, okay, this is 140. Likewise, we can take for other things also into 2.5. Any number is fine. We can take for this also, it's not a problem. But you'll be having 0.5 as the answer. Then you have to solve the problem. Okay. It's better for us to solve this problem, I think so. You know simultaneous equation? No? How to solve the simultaneous equation? Maybe if you see, you may relate it. Okay. See here, this is 140 I got, 35, 140. Okay. This one, Which one we can do? This one, or this one? This is even. It will be easy for us. So 74 into 2.5. That is 37 into 5. 2 into 2.5, 5. 37 into 5 is 185. 185. Right? What they are given is, if I substitute 35 and 140 in the equation, y equal to ax plus b. Y, that is 140 equal to a. A is there. X is 35 plus b. Then y equal to 185 equal to a into 55 plus b. All right. So 35a plus b equal to 140. 55a plus b is 185. This is linear equation of two variables. If I subtract this, this is known as elimination method, subtract this, minus minus. This one would get cancelled, b minus b. Here it is 55 minus 35. 28 equal to 45. So a equal to 45 by 20. That is 4.5 by 2. That is 2.25. 2.25. When I substitute this 2.25 in any one equation, 35 into 2.25, 35a plus b equal to 140. So I have to multiply 35 into 2.25. This can be segregated into 2 and 0.25. 35 into 2 is 70. All right. 0.25 is 1 by 4. All right. So 35 by 2 is 17.5. 35 divided by 4. 8. Remainder 3, 0, 7, 5. 8.7. So the answer is 78.75. The total answer. See, I can segregate the numbers and simply multiply and get this. All right. It will be easy for you in this method. Actually, these are not a difficult task. We can segregate, or else if you multiply this, it will be 3 terms. There are 2 points. Everyone will get confused. They'll blank out and won't be clearing it at all. There is a lot of opportunities for us to do unforced error, unforced mistake. So we have to be strong here. Then it is, if I take the 78.25 here, it becomes 78.25 here. It becomes b equal to 140. B equal to 140 minus 78.25. So 140 minus 70 is 70. 70 minus 8 is 62. 62 minus 0.25 is 61.7. So the desired equation is A, we got y equal to 2.25x plus b 61.7. This is the desired equation. See, they are related, the relation between the forearms and the height, and got this. This is not option. This is the real answer. This is the real answer. If you know this, you can easily find your height, right, with this relation. Actually, this is a true problem, which we got from the desired data of forearms and Likewise, we can relate our height to our fingers to our palm or foot. It can also be related. There will be some beautiful relation in between that. That relation only they are trying to get using these problems. All right. All right. Find the height of the person whose forehand is 40 centimeter. Forehand is 40 centimeter. We got the relation, isn't it? We got the relation now. They're asking to find the height of the person whose forearm is 40. So 2.25 into 40 plus 61.75. So that is 22.5 into 4 plus 61.75. So to multiply anything into 4, I will double 2 times. So 22.5 double is 45 into 2. This is 2 into 2. So 22.5 into 2 is 45. 45 into 2 is 90 plus 61.75. So 151.75 would be the height. Okay, centimeters. If you divide by 2.5, you'll be getting in inches. All right. So the third problem using this is, the third problem is find the length of forehand of a person if the height is 53.3 inches. Height is given as 53.3. So first we have to convert into if we could use the inch itself, we'll be getting the answer in inch. We can write it in inch itself. Or else, if you want to convert into centimeter, you can convert by multiplying with 2.5. So let's try to work out with 53.3 itself. 53.3 inch equal to 2.25 x plus 61.75. Right? No, we have to convert into centimeters since both are not in their fraction. What it would become? It would be negative. This one would go here. It would become negative because both are not in terms. This is in centimeter. This is in inch. So to convert this into centimeter, we put into 2.5. What is 2.5 is? 25 by 10. All right. That is 2 times 5. 5 by 2 is 2.5. So 53.3 into 5 divided by 2 equal to, we have to minus this 61.75 equal to 2.25x. Right? Then, like I told, if you want to multiply with 5, half of it into 10. So it would become 2 times. 5 would be divided 2 times. Remainder 1, 6 times. Remainder 1, 0.6 times 5. Into 10 is 266.5 divided by 2 minus 61.75 equal to 2.25x, which is 9 by 4. That is into 100 divided by 100. 9 divided by 4. It will be 9 divided by 4. So when I cancel this, 133.25. 133.25. All right. Minus 61.75. 133.25 minus 61.75. So subtract properly or else we'll be getting wrong answer. What I will do is I won't confuse everything. I will minus 60%. I will be getting 73.25 here. Then I will minus 5. Minus, sorry, 1. 72.25. Then I will minus 7.5, 0.75. I'll be getting 71.5, right? 71.5 equal to 2.25. I can divide this by 2.25, or else I can convert into 100 divided by 100. It becomes 225 by 100. So 9 in 25 table, 9 divided by 4. Multiply 4 here, divide 9 here. So 71.5 into 4 divided by 9. All right, equal to x. Next step. Multiplying by 4 is 2 into 2. Right? Or else you want to cancel? Multiply. So 71.5 into 2, 143. This also, the process is 70 plus 1.5. 140 plus 3, 143. 143 into 2, 286. Okay, 286 divided by 9 equal to x. 1 time, 3 times. Remainder 1. 16, only 1 time. Remainder 7. 70. 7 times, 60 pieces. Again 7. So, this elbow would be 19.77 centimeters. When we think properly, you would be getting the result simple, right? It will be simple as possible. How I multiplied 71.5 into 4 into 2, doubling it, 143 into 2, 286 divided by 9. Then I cancelled, simplified it, and got the result. Okay. When you think, you can answer. Okay. So this is all about the last exercise. Okay. 1.6. It is almost 1. What we can do? We can proceed. Continue tomorrow. Right. So I'm really happy you coped up really well. Right? If we go in this manner, you won't be needing more time for mathematics. You'll be completing the mathematics immediately. I'm happy you're really faster. You're really already good with some strong fundamental basics. You just have to improve your speed. If you improve your speed, you will be twice as fast as your friends. Okay. I think before 13th, if we go in this order, this timing, before 13th, you'll be completing more than 80% of mathematics. All right. So, what do you think about the way I teach?
Lot of techniques to teach.
I teach for differently for each and every one. Right? Since I could first, what I did is I analyzed you how strong you are in basics from the exterior classes. I found out you are really good at that. So we almost within this time itself, and you are good in intake also. Your concentration is also not deviating. Right? So you're really, really doing your best. Some people would be slow. They won't be having that strong base. For them, the way I teach will be totally different. Because each and every student is unique and different. They have the talents. There are only 2 types of students available. All right. School or a lot of people or a society or community, they decide between strong student, weak student, good student, bad student, average, above average, below average, like that. Actually, there is no segregation between two. Students are students. The people who are known as smart or above average or intelligent, good student, are the one who understood the basics, and after understanding, they are applying the concept. The one who is not doing, who is yet to do that practice, will be also a good student if he practiced and all his mistakes are removed. You could see that you have to be somewhat sharper in your questions. If you're sharp, automatically you would get to that result. Right? When you check into it, when you think into it, definitely you'll be getting the required. So this is what we are going to do. If you check how much is the balance in your chapter, this is just how you're going to represent. I'm not going to teach you, don't worry. Almost 80% is over. This 20% is just application. One, set of ordered pairs. Then second one would be table form, tabular column, X value, Y value. Then arrow diagram, which we already did, and graph, which we already did. Set of ordered pair is Brewster form. All right. Table is like this. X, Y. If X equal to 1, Y equal to 2. Like this. All right. Arrow diagram, we already did. Graph, we already did. Pointing. All right. And vertical lines. If you put a vertical line on a graph, what you would be getting, or that shape, what you would be getting. How many X, how many value of X, or how many value of Y you would be getting. Right? We'll be going through this and just showing you what it is. For this, they're given a function 3x minus 1. So applying 1, 2, 3, and 4, you'll be getting 1. After getting that, you'll be putting it in arrow diagram, tabular form, set of ordered pair. You have already done the A cross B and the same application, right? Nothing. Then types of function. This is the last one. Type of function. 1 to 1. If each and every domain, every element of domain have a very unique image, then it is 1 to 1. It's not like 2 also to C. 1 to 1 function. Many to 1. And many to 1, if two function have two elements of domain have same image, then it is many to 1 function. Right? 1 to 1 function is also known as injection. 1 to 1 function is also known as injection. Then many to 1 function. Here, P1 and P6 is going to many to 1 function. Right? Many to 1 function. Many to 1 function. Then on to function. If the domain and codomain, domain and range are same, then it is onto function. If domain and codomain, codomain and range not same, it is into function. Okay. See here, domain is 1, 2, 3, 4, but range is television, washing machine, and water alone. So this is into functions. When we combine this 1 to 1 and onto 1 to 1 and onto into 1 to 1 and onto, it is known as bijective function or bijection. All right, that is bijection. 1 to 1 on. All right, that is 1 to 1. It is unique and also codomain equal to range. Then it is bijective function. See, this is the cyber circle for each element. See here, A will be written as D will be written as A. E would be written as B. That is 3 steps. If I'm writing M, if I'm writing SAI, psi, then for S, I'll be writing P. For A, I'll be writing X, P, X. I will be writing F. Psi will be written like this. This is coding. This is coding. The detectives and things they be doing. No, we need lot of these kind of things. We need lot of this kind of things. So this is cryptography. It is used in cryptography. If we want to send secret messages so that the enemy won't be getting the answer, it should be written in crypt. The answer, the decision and everything can be passed. So while in World War or while in any war or something, they'll be using this cryptic message. Not only this alphabet and numerical also will be combined. And they'll be doing that. They are just forming one function, one rule and formula. Like if I'm writing VIJY, this one would be 3 letters afterwards. This one would be number. This one would be 4 letters afterwards. This one would be number. This one would be 5 letters. So it will be a combination. So till Vijay, it will be totally different. They won't be deciphering at all. So we have to analyze, check, okay, what are the combination it goes. And then we have to proceed. See, hello can be written as form. So that is the use of these functions, right? That's what this is. See here, one-to-one and in onto function. One-to-one and onto. That is bijective. One-to-one, here to many to one and onto. Many to one onto function. So that's the difference. And this horizontal test, what it will do. And again, we'll be just doing the same arrow diagram and thinking about we'll be going through one image. From one image, from the formula, we'll be deriving the other one. This is what it will be happening here. And special cases of function, constant function. Everything is pointing to one. All the elements will be having one only. Then identity function. X to X, Y to Y, Z to Z. This is known as identity function. Then real value function. It can be any real numbers, subset of real numbers. So after completion of this, here also, they'll be applying the same concept, what you did before, but it would be a slight difference. These are 5 marks. Slight difference. That is, if it's lesser than -2, X is lesser than -2, then we have to use this. If it's equal to or greater than -2, lesser than 3, then we have to use this formula. If it's greater than 3, greater than or equal to 3, we have to use this one. So F4, we have to use this one. -2, we have to use this one. 4, 2 into F of 1. F of 1, we have to use this. F of 4, we have to use this. 2 into F of 1, we have to. Then F of 1, this one. -3 into F of 4, this. Divided by F of -3 is this. So whatever you did in first 2 exercise, you'll be applying that concept one by one, one by one. Right? Right? Let's complete it. If you are listening, I will go on. I told you, no, when I'm teaching, I'm totally different. Now I'm teaching at least 10 to 15 hours per day. Whenever I teach like this, I'm really happy. I never care about, okay, I'm getting bad sleep or something. That's my passion. I teach all subjects. Just like this. If it's science tool, one lesson will be taking hardly, even reading through the whole lesson, explaining, understanding, pointing at everything, will be taking hardly 1.5 hours. So easily we can, with this time limit, we can easily complete 2 or 3 lessons. When we do this science and mathematics, complete the science and mathematics, it will be like, when you're going to school, it will be like, I have only 3 subjects. I already completed this. So you'll be without any pressure. That's how I completed for 2 people. 10th standard, I completed maths and science. Within 15 days, I completed both. Now, when they're going to school, it will be like revision for them. Whatever teacher takes there, they would be ready to answer the question. And if they have any more doubts in that, they can also clarify with the teachers. And this video will be uploaded directly. If they have any doubt regarding one side, they can go there and check with this video and rectify those mistakes. This is how we have to do. Thank you. You are a very good student. You listened really well and you concentrated really well. If you're doing this, you're going to go elsewhere. So you're having a very good talent. If you use this talent, definitely you're going to go to places. If you want to become a teacher, don't just become a teacher, become a professor. Right? You have the talent and capability, and use the talent, apply it. Don't deviate from your path. You can definitely be free. You can enjoy yourself, extracurricular activities, whatever extracurricular activities you do, whether it's dancing, singing, or whatever it is, you can. If you cut short your time and complete your work first, for all the extracurricular activities and everything will be having time, you can be relaxed and work on it. You know, the people who are getting state ranks also, or good ranks in me, they will be good in extracurricular activities like dancing, classical singing. They'll be doing all those things also. That is, they have completed that work and they are using the extra time for all the extracurricular activities. They can see movies, they can play games and time limit. You complete this, you proceed. Right? Okay. You have a laptop in your home? Okay. What we can do then? With this working. I'll save this. We'll be working with this Excel. Actually, we are recording this. We can easily upload it in YouTube also and send it to you. Whenever you want, you can check the notes and correct yourself if you need a doubt in one part or something. Okay? Think properly, work effectively. Okay? You can end the session then.